I, Amit Sharma, welcome you all to Mathematical Coaching Center. In today's class, we'll do logarithm. By the end of this video, you will be perfect with what is logarithm and its use to solve numerical problem and its application in real life. So what is logarithm? You can see here, logarithm is the inverse function of exponent. So it's an inverse function of exponent. So you can see here what you have an example. 2 to the power cube equals to 8. So as you know that this 2 is your base. So this base, if I'll represent in logarithm, log base 2, and this 8 will come this side and this power will go this side. So simple, logarithm is nothing, is the inverse function of exponents. So exponents is this way, logarithm we write this way. Now what you have next is that what is the use of logarithm? So logarithm are convenient way to express a large number in a simple way, and it's used to make the complicated calculation also simple. But due to use of calculator and the computer, this benefit is slightly less important today. Now how are logarithm used in real life? Logarithm is mainly used to solve the exponential equation, and even it helps us to measure the intensity of sound, earthquake, and even the pH balance in acidity and the alkalinity. So without further delay, let's start today's class. So logarithm were developed for making complicated calculation also simple. But you know that what happened is that because of invention of computer and the calculator, so what happened? The use of logarithm is now no longer necessary. But in mathematics, still we use this logarithm and the exponential. So what is this logarithm? Logarithm is the inverse function of exponential. Okay, exponential or indices. This you'll go in detail in class 11. Okay, so what is logarithm? Logarithm is function, and we represented it by log. So what happens is that simple, it's an inverse. So plus inverse is your minus, similarly multiply is your divide. Similarly you can see here what you have, 2 to the power cube equals to 8. So 2 is my base, it's called as base, and you can see here this is my exponents or index or power equals to 8. So this, how can I write in logarithm is that simple, I'll write log. Okay, can you see this 2 is my base, so it will be at suffix this way, and this 8 equals to how much? It will be 3. So logarithm is just the inverse function of exponential form. Okay, so this is your 2 is in suffix. Similarly you can see here we have an example. So 10 square equals to 100. 10 square is 10 tens are 100. So how can I write this? I can write this as log. So this base, this 10 is base, so base will come at down, and this will be your 100 equals to how much we will have? 2. Okay, so to use the calculation, so what happens is that if you use the logarithm, the calculation is very simple. So that's why you used to use logarithm. Now you can see here 3 to the power minus 2 equals to 1 by 9. I think so now you have been perfect. What is my log? We have to write. What is my base? Base is my 3. So what will be this? 1 by 9. Since it's fraction, so I'm writing in bracket equals to how much I'll get? Minus 2. Similarly we have another example. You can see what you have, 10 to the power minus 2. So what can I write this? Log base 10 0.01, since it's decimal, so I'm writing in bracket equals to how much it will be? It will be minus 2. And what you can see is that the base 10, in base 10 the calculation becomes easy. So this logarithm with the base 10 is called as common logarithm. Okay, now let's see different types of logarithm. So here most common type of logarithm. So in your syllabus it's only common logarithm is there. So what is this common logarithm? If there will be base, if the base will be 10, then we call it as common logarithm. So you can see for example log 10. Usually what do you write? Log x. Simple, if you'll see in your exam, if it is log x, then you have to think that base is 10. So this is your common logarithm. In common logarithm we don't write base because we have to think that it is 10 only. So means log 10x. Okay, so what happens is that this is your common logarithm, and this is in your syllabus. Similarly what you have is that another is natural logarithm. This you will do in class 11. So in natural logarithm what happens is that base is e. E is your exponent, okay, and the value of E is 2.718. So in this, what you'll write? Log base E, natural log, or we write it as ln. Okay, simple, usually ln x. So what is this ln x means? Ln x means it's log base E x. So this part is not in your syllabus. This is only in your syllabus. So what is there in your syllabus? Common logarithm. So what does the common logarithm means? Base will be 10. So why this base is 10 is that it's called as common logarithm is that our numerical will be easy. So simple, you can see 10 cube is your 1000. So what can I write this? Directly log, what can I write? Base is 10. So directly I can write 1000 equals to 3. So see, I got so simple, only 3 value I got. So this way our calculation will be easy. So that's why we used to use logarithm function to make our numerical easy. But nowadays, because of the use of calculator and the computer, logarithm we don't use. Okay, but still we use as a function in some numerical problem. Okay, so now let's solve some numerical problem from this chapter. Some properties you should know before doing the some numerical. You can see here what you have is that a to the 0 equals to 1. As you know this from indices, yeah, e to the 0 equals to 1. So anything to the power 0 is 1. So how we can write this in logarithm is that log, what is my base? A, so 1 equals to 0. So what you got from here is that whenever there is log 1 always it will be 0. Suppose it's log, suppose I have base anything, it can be 3 1. So this will be here, the value will be 0. Okay, so what you got? So that implies that log 1 will be always, the value will be 0. Similarly, you can see here what you have, a equals to a. Actually there is on top there will be 1, a to the 1 equals to a. So how can I write this in logarithm form? So base is my a, this is also my a equals to 1. That implies that if the value of this and the base are same, if the base both will be same, then the value I can write 1 directly. Similarly log, so what will be 3 and 3, base is also 3. So what will be the value of this? It will be directly 1. Similarly log 10. So already I have told you this is your natural log. So in this base will be 10. So what can I write? Log 10 directly I can write 1. So in this what you can see is that log a x equals to log a y. So in this the log is same. That means what can I write is that directly this 2 will get cancelled. Actually we will multiply by exponential. Okay, so what happens that this 2 will go, then what will get? Implies that x equals to y. So this is our another property. Similarly if I have like this, log y equals to log z. So already I have told you this is your log, that means it's your natural log, means suffix there is 10. So this log and this log will go, implies that directly what can I write? Y is equal to z. Okay, so there are more properties we will discuss in another video. So now let's solve numerical problem using this all properties. So here we are with some question. It's from exercise 9.1 ML Agarwal. So you can see here what you have. Convert the following in logarithm form. So we have to convert this in logarithm form. So now I think so you are perfect. So what is my base? Base is my 5. So what can I write this? Log base 5 will be down. So what do you have? 25 equals to the power. This is my answer. So similarly what is my base? 7. So it will be log 7. What will be here? 100 equals to x. Similarly this log, what do you have to write? This is your base. So base will be down. What do you have the value? 1 equals to 0. So already I have told you that whenever there will be log 1, whatever will be base, the value always will be 0. So what will be this? Log, what is my base? Base is my 3. What is my value? 1 by 9 equals to, what is my power? Minus 2. Similarly what will be this? Log, what is my base? 81. And what is this? 27 equals to, the power will be on the other side. 3 by 4. So this is your final answer. Similarly what you can do, this logarithm form you can write directly in exponential. So how to write? See, you can see here base, this base square equals to 25. Similarly we have another question. You can see here in this what we will do is that they had given us logarithm form, will change in exponential form. So how we can do? So 2 2 to the power 5 equals to 32. So how to write? 2 to the power 5 equals to 32. Hope so you got this to this equals to this. Similarly, what will be this side? What will be my answer there? 3 this minus 1 equals to 1 by 3. So this is my exponential form. This also how can I write? 10 to the power minus 3 equals to 0.001. Similarly, what will be the answer of this? What can I write? 8 to the power this 8 to the power 5 by 3 equals to 32. So this is my exponential form. So here we have, by converting to exponential form, find the value of this. So what will be the value of this? This is important for your exam. So what you'll do, our first step, we'll take let log base 2 16 equals to x. So we have taken log let. So what we can do, how to change in exponential form? Can write like this: 2 to the power x, this will go this side, 2 to the power x equals to 16. 2 to the power x. Now what I'll do? I'll do the LCM of 16. So what will be the LCM of 16? So 16, 2 8s are, 2 4s are, 2 2s are, 2 1s are. So how many 2s are there? 1 2 3 4. So how much I got? 2 to the power 4 I can write. So already we have done in indices. If the bases are same, the power will be same. That means directly I can write x equals to 4. So therefore what I got the value? Therefore log 2 16 base 2 16 equals to 4. So this is my final answer. Hope so you are clear. Let's solve another question, similar type of question. Now we have another question. You can see here what you have, log base 9 27. Okay, so what you'll do, our first step will be let log 9 27 equals to x. Now as you know, what is the rule? 9 to the power x, what you have to write? 9 to the power x equals to 27. Now since we have to change in exponent form, always we have to change in the lowest. So what will be this? 9, we'll do the LCM now of 9. 3 3s are 9, 3 1s are. So what I got? So 9 I can write 3 square. 3 square and outside what do you have? X equals to, similarly I have to change 27 also. What will be the LCM of 27? 3 9s are, 3 3s are, 3 1s are. So how many 3s are there? 3. So 3 to the power 3. Now what can I write? 3 2 into x, 2x equals to 3 to the power 3. Now you can see what you have, bases are same. So 3 3 are same. If the bases are same, the index has to be same, implies that 2x equals to 3. So therefore what I'll get? X equals to 3. This is multiply. When you go to that side it will be divide. So therefore I got the answer, x equals to 3 by 2. So we'll put the in that question. So 9 27 equals to x is almost 3 by 2. So this is my final answer. So here we have another question. So what you'll do, what will take log 10 0.01 equals to what will take x. So how can I write this? As this into this, so this upon this, so 10 upon x equals to 0.01. so this what can I write? 10x, or so this I can write 1 divided how many zeros? 1 2, so 2 zeros will be there. Now this I can write 10 to the power x equals to, as you know, this how many zeros are there? 2 zeros, so 10 square, or 10 to the power x. This is your positive. So to make it positive, I'll take it up. So when I'll take it up, since it's positive, so it will be negative. So minus 2. So now you can see bases are same. So what will be? If the bases are same, that means x equals to minus 2. So therefore I got log of 10.01 equals to minus 2. So I got the answer. So before doing this sum, you have to be perfect with the indices chapter. Okay, because we have to use the indices rule. See, you can see 1 by 10 square is there. So when I'll take it up, what happens is that the sign changes. So first you have to be perfect with the indices, since the logarithm is the inverse function of exponents. Okay, so now let's solve another question. So we have another question. So what we can do similarly here, obviously we have to take let log of 0.5, in this decimal is there, 256 equals to x. So as you know the rule, what you have to do, exponent, so this upon this, so what will be this? Implies that 0.5, I can write 0.5 upon x equals to 256. Or what can I do this? 0.5. Can I write like this? 5 upon 10 2 to the power x equals to 256. Now I have to do the LCM of 256. So 256 LCM. 2 1s are 2, 2 2s are 4, 2 8s are 16, 2 6s are 12, 2 4s are 8, 2 3s are 6, 2 2s are 2, 16s are 2, 8s are 2, 4s are 2, 2s are 2, 1s are. So how many 2s are there? 1, 2, 3, 4, 5, 6, 7, 8. That means I can write this as 2 to the power 8. Now you can see 5 and 10 is there. So can I cancel this? 5 1s are 5, 5 2s are 10. So this I got, or what I got? 1 by 2 to the power x equals to 2 to the power 8. So already I have told you that anything to the power 1 is 1 only. So 1 to the power x, it will be 1, but this will be 2 to the power x equals to 2 to the power 8. Okay. Now since the op 2 is in numerator, so this I'll take it up. So when I'll take this up, the positive sign will be negative. 2 to the power minus x equals to 2 to the power 8. Now you can see the bases are same. That means the power has to be same. That means what I'll get? Minus x equals to 8. Now I'll do multiplying by 8. So when I'll do multiplying by 8, what I'll get? Therefore x equals to minus 8. I am doing multiplying by 8. So what I'm doing? Minus. This side also minus. So minus minus plus minus 8. Okay. So therefore I got the value of x equals to 8, and the value of this is your minus 8. Hope so you are clear. Just I am solving some important question on different types of question. Okay, you can practice another question from your book. Now let's solve another question. So here we have another question. Solve the following equation for x. That means we have to find the value of x. Why it's equation? Because equals to sign is there. Exercise 9.1 is not that much important, but what happens is that in this you have all the basic rules are there, which will you have to apply in the next exercise. Okay, so next exercise is more important than this exercise. So now what you have to do is that in this we have to find the value of x. So as you know, what happens is that how we can change in exponents form. So this I can write x square. Yeah, this square equals to how much it will be? 25. So now this is your x square. So as you know, 25 is your 5 into 5. Yeah, if you do the LCM of 25, what will be? 5 5s are 25, 5 1s are. So how many 5s are there? 2 5s are there. 5 square. Now you can see which rule we have to use. In this, the powers are same. Power same means basis also has to be same. Therefore, x equals to 5. So I got the answer. Now let's solve another question. In this, what you can see is that log base 9 x equals to 2.5. So what can I write this? Or 9 to the power 2.5 equals to x. So this, what can I write? 9. If you do the LCM, 9 LCM will be 3 3s are 9, 3 1s are 3. So how much I got? How many 3s are there? 3 square. 3 square. But what do you have outside? 2.5. So what can I write? 25 upon 10. Can I write like this? Because 1 point, so it will be 10 equals to x. Now I think so it will get cancelled. 2 1s are 2, 2 5s are 10, 5 1s are 5, 5 5s are 25. So what I got? 3 to the power 5 equals to x. So this is my final answer. So therefore x equals to 3 to the power 5. Or you can write this as 3 into 3 into 3 into 3 into 3. So you can multiply and you can write the answer, or you can leave it in this much only. Okay. So here we have next question. So log x is there. So which log is this? This is your natural log, because they haven't given us this. That means always, if they'll not give us, there will be always 10. So what we'll do? Or this is your log base 10 x equals to minus 1. So what can I write this? 10 this, yeah, 10 to the power minus 1 equals to x. So I got the value of x. So therefore what I got? X equals to 10 to the power minus 1. Or this I can write, since it's negative, to make it positive it will go in lower. So I got x equals to 1 by 10. So here we have another question. You can see log base 2, in this we have bracket x square minus 1 equals to 3. So how can I write this? 2, this 3 will go that side. 2 to the power 3 equals to, what can I write? X square minus 1. So 2 to the power 3 is 2 into 2 into 2. So this will be 8. This minus 1, when I'll bring this side, it will be plus 1 equals to x square. So what I'll get, 8 plus 1 is your 9 equals to x square. So now what you have to do, rooting both the sides, or this will be x square equals to 9. Therefore I can write x equals to this square. When it goes, that's it will be under root 9. So under root 9 means it's your, what can I write, 3 into 3. 3 into 3 means 2 3s, it will come only 1. So we can write plus and minus. So already I have told you, whenever your number comes out from the square root, we have to write plus also, we have to write minus also. So I got the answer. So here we have another question. So this will be the last question from this exercise. Okay. So what you can see here, what they are given is that, so this is one of the important question also, given log, what they are given, x equals to a. So what they are given is that they are given us natural log. So natural log means the always base will be 10, and what they are given, log of y equals to b. So this is also natural log, that means base will be 10. So what can I write this, 10 to the power a, 10 to the power, what can I write this, 10 to the power a equals to x. Similarly this, what can I write, 10 to the power b is equal to y. So therefore what you have to find, you can see xy. So therefore xy. So what I got just now, x value 10 to the power a. What I got the value of y is 10 to the power b. As you know that the bases are same, 10 10 bases are same. Bases are same means the power should be added. So 10 to the power a plus b. So I got the final answer. So logarithm, it looks complicated, but it's very easy. But you have to know the basic properties of the logarithm. Without knowing that properties, you can't do. So whatever I have done this sum, please practice that nicely. It will be helpful for our next exercise. So please, if you like my video, please like, share and subscribe to our channel.